Steel Profiles podcast is brought to you by AISC Continuing Education. Visit aisc.org/seminars to find a seminar in a city near you.
Welcome to another episode of Steel Profiles. I'm your host, Margaret Matthew, Senior Engineer in the Continuing Education Department at AISC. My guest today is Lawrence A. Kloiber, P.E. Larry earned his bachelor's degree in civil engineering at Marquette University in Milwaukee, Wisconsin, before beginning a career that has spanned more than 40 years in the structural steel construction industry. Larry went to work for LeJeune Steel in 1967, starting as a structural engineer, and went on to hold positions of chief engineer, vice president of engineering, president, and CEO. Larry has worked on many impressive projects, including the Minneapolis Convention Center, the Mall of America, and Chicago's Millennium Park. Larry has been a longtime friend of AISC, serving on the Specification Committee since 1986, as well as many other committees. In 2002, Larry received AISC's Lifetime Achievement Award, and in 2004, Larry was the recipient of the T.R. Higgins Award. Welcome, Larry. Thank you so much for agreeing to be my podcast interview today and taking the time to talk to me.
Oh, Margaret, this is an interesting experience for me, and I'm looking forward to it.
Good. I'm always glad to hear that. So, what motivated you to go into engineering?
Well, my father was a county highway foreman, and I had on the opportunity on occasions to go with him to projects, particularly if he was working on bridges or things like that, which I found fascinating. I can still remember the time that I watched my dad remove shoring from under an old concrete bridge, and I was worried that it might collapse on him. And then afterwards, they used a bunch of dynamite and could barely blow a hole in the bridge. But
there was no need to worry.
Yes.
So you earned your bachelor's degree from Marquette University in Milwaukee, and then your first job was in Santa Clara, California. How did you make it all the way from Wisconsin to California for your very first job?
Well, I was interested in heavy construction, and California, in the Department of Water Resources, was starting a major water project that was going to involve construction of several dams and hundreds of miles of aqueduct. And so California was sort of the land of opportunity. I'd never been there before, and I thought I wanted to go out and see it and experience it. And
so you'd never been there, but you moved there for a job?
Yes.
Wow, that's adventurous.
Yeah, we were fortunate when I got out of school in the fact that people were searching for engineers, and so they had people interviewing along with steel companies and other people interviewing people at school, inviting you out to work there.
Oh, that's nice.
Yes.
So did you get to work on those big projects?
I did some surveying. It was interesting to go back years later and see where you had just driven survey stakes in the line to now see an aqueduct that was 150 feet across at the top and ran for miles, And so that was really interesting to go back and see that.
So your job in Santa Clara was as a structural plan check engineer.
Yes, after I got married, traveling throughout the state surveying and doing construction wasn't as appealing, and so I went to work for the city of Santa Clara and got assigned to the building department to do structural plan review. It was a great experience.
Did that give you insight later on in your career when it came time to satisfy the building code officials?
Well, it helped me to understand the role that building officials play in the safety of our structures and that. And it also made me realize that people in the design construction team, like builders, developers, and engineers, would accept strict rules as long as they thought they applied to everyone. It had to be uniformly enforced. And I think that was an important thing. The other thing about the job is it was the perfect place to work when preparing for the professional engineering exam, because before we could issue a building permit, the engineer of record had to submit detailed calculations on the structural design of the building. So I had the opportunity to review some of the top flight engineers in Northern California doing designs. I mean, I saw work from people like Dr. T.Y. Lin and that. So it was great preparation for the professional engineering exam.
And you probably also saw calcs the way that you didn't want to do them.
I had one individual who was really sort of plan stamping. I got into a few battles with him, and a couple of years after I left California, I saw where one of his buildings, fortunately not one I had reviewed, had collapsed due to ponding.
Oh no.
Yeah, fortunately it was just a structural collapse and there were nobody injured and stuff like that. But yes, it did make me aware that there were some people that were sort of shortcutting things too.
Yeah. So then you went on to be an AISC regional engineer early in your career. So what was your region and how did you end up with that job?
Well, I was back in Minneapolis at that time working for the city doing structural plan check. And Bob Lorenz, who's now retired from AISC, had been my lab instructor at Marquette in Steel Design Lab. And he was the regional engineer, and he was promoted to be Bob Desquay's assistant in New York City. So I applied for the job, and I can remember the interview with Bob and going to 101 Park and coming back on the plane, and so happened I got bumped to first class, so I was flying high when I got home celebrating my new job.
Wow. So what did you think of that job as a regional engineer? I mean, what were your responsibilities at the time?
I was, at that time we had 32 regional engineers, and I had responsibility for Minnesota and the Dakotas and a little part of Wisconsin. While I only worked for AISC for a few years, it began a long-time association with AISC. For example, my first assignment as an AISC engineer was to go to Lehigh for a week-long seminar on the plastic design of high-rise structures.
Oh.
And it was an incredible week of lectures and being associated with the top steel design and research people from around the world. I had the opportunity to meet people like Dr. Lynn Beadle and John Fisher and Ted Golumbos, you know. In the evenings, we'd listen to lectures like Dr. Nathan Newmark talking about the seismic design of the Tower Latinoamericana. After all these years, people like John Fisher and Ted Golumbos are still friends some 40 years later, you know, so it was just a fantastic opportunity.
So then you went to work for LeJeune Steel Company,
Yep.
who I believe you worked for the rest of your career. Still do.
Yes.
LeJeune is now a very large fabricator in Minneapolis. What made you want to go work for a fabricator, and what was it about that work that appealed to you over just working in a regular design office?
First of all, I think I've always been more hands-on and like construction. So, I mean, I thought about design offices, but that was more sitting at a desk, and I like to be involved in the building of the project. But going to work for LeJeune was a very difficult decision, and I agonized over it. My wife can tell you how concerned I was in that, because I really liked working for AISC and the status that AISC gave me as far as acceptance by engineers such as the people at Lehigh and that. But LeJeune Steel at the time was the smallest of 6 fabricators here in Minneapolis, but I saw the opportunity to grow. And over the next 30 years, the other 5 fabricators all went out of business, and we grew to be one of the largest fabricators in the upper Midwest. And, you know, I had the opportunity to go from a sales engineer to chief engineer to ultimately president and CEO before becoming a consultant to the company. So it's been really a lifelong career, and I've enjoyed it.
You've worked on some very famous projects, like the Mall of America and the Minneapolis Convention Center. Do you approach these types of monumental projects any differently than you would any other project?
There's a lot of planning in these projects, and I always like to think on complex projects. I try to understand the structural system, not just worry about doing beams and columns, because you need to know what the structure is like so you can understand the intent. The design drawings are not always going to show everything.
Right.
And so ideally you'd like to think, what did the engineer really want us to do here? We can do it, or maybe even find a way that he thinks would be better. And so that's primarily what you do on projects like that.
Did you have a mentor?
Well, I had several people in the company, in particular one senior individual who taught me some basics of fabrication and concepts and that. But I also continued my role with AISC, working on committees where I worked with people like John Griffiths from Paxton Veerling and Jim Hosapple from Inland Ryerson, and even Jim Wooten from AFCO. And these are all memorable people who taught me an approach to engineering that I valued. I also should say that the Central Fabricators Association played a key role in my fabrication management experience, and I can't say enough about the importance of serving on industry committees and attending steel conferences and seminars like this in order to develop your career.
You're known for having a very close rapport with the engineers, contractors, and owners that you work with. How do you develop these close relationships?
I've been told that I have an ability to listen and respond to what others are saying. I always approach a project with the idea that real success is when everybody on the team is successful. And as a specialist in steel design and fabrication, I sometimes possess knowledge that a general practitioner may not have. And I always try to carefully explain my position so other team members are not embarrassed. I do not believe in playing I gotcha, trying to say, oh, this is wrong. I want to say, this is what I think might work better. And I found people are appreciative of it. I remember one experience where I was giving a seminar. I mentioned how one engineer became upset when I pointed out a problem. And one of the gentlemen in the back of the audience raised his hand and he said, Larry, if you ever find anything wrong with my project, I want to know about it.
Well, that's always the best attitude to have, I think.
Yes.
Do you have a project that you're most proud of? You've worked on so many.
Well, that's a tough question. I mean, there are projects I remember because of the associations, the other team members, and how well we worked together. Others I managed because we managed to prevail, like Millennium Park, and that. But I think you mentioned the Minneapolis Convention Center, and that's one that I will always remember. It has a unique structural system consisting of 3 lamella domes surrounded by an HSS space frame. The geometry required a number of unique, complex connections that had special material requirements. Tom Schlafly was our chief engineer at the time, and without his input and supervision, I'm not sure we would have had the success we had on the project. The material problem, which was unique, was a through-thickness toughness problem due to welding strain. The dome was supported at key points by 6 and 8 inch plates that had 8 or more CJP welded connections to the face of each of these plates. At the time, the steel industry was just beginning to understand lamellar tearing. The EOR had specified ASTM A588 plates with standard CVN testing. My discussions with the mill metallurgist indicated that this would not ensure the through-thickness toughness that was needed for these connections. I arranged for the owner and the engineer of record to have a meeting with John Fisher and Roger Pence at Lehigh, and included John Barsom, who is the chief metallurgist for USS at the time and the USS mill production manager. It was agreed to change the specification to ASTM A572 grade 42 with a maximum thickness of 6 inches in order to reduce the inclusions in the material. The mill also agreed to provide special chemistry for inclusion shape control and special rolling. The testing, it was decided, would consist of through-thickness tension tests at selected locations to ensure through-thickness ductility. This testing procedure ultimately became the basis for the current ASTM A770 through-thickness testing protocol that we use today. So I was very proud of what we accomplished on that structure.
So you were ahead of your time.
Yes, with the assistance of friends like John Fisher, who, because of my association with AISC, I became aware of some of these things. I had the contacts with people like this in the industry. And the great thing about the steel industry is I've always found that people like John Fisher, Ted Columbus, and all these other people are always willing to share with you and help you.
Yeah, share their knowledge and experience.
Yes.
Yeah. Bill Thornton wrote a paper called Connections, the Last Bastion of Rational Design. Do you agree with that connection design is the last bastion of rational design?
Absolutely. I think the work that Bill has done demonstrates this. His contributions to connection design, especially bracing design, using the lower bound theorem, is a perfect example of rational design. So much of what we see in structural design today is pure computer analysis. I'm very concerned about what's happening with complex analysis programs coupled with the surge to BIM, the Building Information Modeling System. I realize that we need these tools to do complex projects that the architects are conceiving these days, but just because the computer can calculate all the second order effects does not mean we should model or design this way. We're finding that when modeling, engineers tend to make all connections either pinned or in some cases rigid. And this makes for easier modeling, but coupled with the complex load combinations required by ASCE 7 can drive large forces into the connections that require extensive member reinforcement. I think the structural engineering profession needs to look closely at how to model complex structures and provide some relief in the connections to avoid some of the second order effects that we find in the large systems today. One of my heroes is Dr. Fazler Khan. I have on my wall his statement philosophy that I strive for structural simplicity. A structural man must not be lost in his technology. I'm afraid that on large structures today, some engineers are lost in their computer technology. I heard a local engineer comment recently that he thought some of the designs he had reviewed were done on Game Boys.
And you probably could just about do that today, the way the technology's going.
Every engineer should read Jim Fisher's Kimbrough Award paper on what is design before sitting down at the computer keyboard. I think that would help them to understand what's required.
Do you have any advice for, maybe for companies that they hire engineers out of school, and, how should they treat that as they come in? Because I think a lot of times you're sat at a computer and said, here, go design this. We use this type of software, to make it back to the basics. And so you could sit and design that building without that software if you had to.
That one of the great things I like about working in fabrication and working in a company like LeJeune is that 40, 50 paces from my desk, I can walk out on the shop floor and see something. And I don't know what can be done to get people out to job sites to see what the structure looks like. I can remember years ago we were doing a project for Caterpillar, and the local design engineer came to our shop, and we walked through, and he looked down at a connection, and he sort of scratched his head, and he said, "Did I design that?" That's what it looks like, So I don't know. I mean, if they can check shop drawings, and get out to job sites and stuff like that, I think it's really important that you are able to visualize the structure in your mind and how the structure is built. That's key to understanding how this thing needs to be connected. For a good part of my career, I always enjoyed going to the job site and meeting with the erection foreman. And of course, usually the first thing the erection foreman wanted to do was take you around and show you the problems, where it didn't fit and that. But it was a good experience. You learned how they put the structure together and what really meant important things to them.
How did you get involved with AISC committee work? As we're thankful that you've always been very involved.
I think in the beginning, LeJeune felt a little guilty about hiring me away from AISC. And so they agreed to do this. And then after a while, they started to see how all this benefit would flow back to the company, and the savings from this knowledge that I could acquire, they became enthusiastic supporters of participation in AISC. So it became a win-win type proposition.
You do serve on the AISC Specification Committee and on the Code of Standard Practice Committee, as well as on numerous other committees for AWS and SEI. Why do you think that committee work is so important?
Well, from my role on it, I think it's important to bring construction experience into code writing. I can give you one little example. Years ago, RCSC used to require that all high-strength connections were fully tensioned. And even though research showed that snug-tight connections would perform structurally the same way, but it was thought that it was easy to tension them, so let's do this. And the committee was sort of reluctant to change. I reported about a case where there was a simple warehouse in Minneapolis that was being refinanced. And so the insurance company had the building inspected and found that these bolted connections were not fully tensioned or uniformly tensioned. And so because this was a code requirement, before they would finance the building, they had to go back through and retension all of the bolts in this simple one-story warehouse. When John Fisher heard this, he said, well, that's ridiculous, And so with his support and the support of people like Bill Millick and Ted Winneberger of WW, the RCSC changed the specification, and we've gradually gone more to snug-tight connections, recognizing the value and the economy of these things. But this is because of input from, people like myself and Ted Winneberger and things like that.
Yeah, people who know what's actually going on out in the field.
Right. I would also say about the committee work is that personally I think my involvement in AISC has been the best postgraduate course in structural steel design that I could have ever had. I've had the opportunity to serve on AISC research task groups at most of the major universities in the United States. I've had the opportunity to listen to some of the top academics and practitioners argue code points and agree to language. So I get the background on why things are done. It's just been a great graduate course. And so it's been very beneficial.
I think that's one of the most interesting things about the committees, AISC, and I'm sure other committees as well, is you know what the intent is when they put something the way they write it in the spec or in the manual. You know the background and you know the intent of what they were trying to get at, whereas I think a lot of engineers don't necessarily have that information, so it's harder for them to figure out what AISC or the code wants them to do.
Yes, it's interesting to know the background and the history and even some of the personalities and discussions that went into some of these.
Yes, I think they're fascinating. In 2002, you received AISC's Lifetime Achievement Award, which is special recognition for many years of service to the structural design, construction, and academic communities. What did receiving that award mean to you?
Well, I think recognition by the fabrication industry of my work is sort of like being inducted into the Hall of Fame for me, you know, to know that the people of the AISC and the academic community recognize what I've done, and the contribution is just gratifying.
You are also the 2004 recipient of the T.R. Higgins Award from AISC, which recognizes the best paper on the design of structural steel design. What was your paper about? I
mentioned earlier that my mentors were people like John Griffiths and Jim Wooten. My paper was really about simplifying shear connection design. Simple shear connections that make up about 3/4 of the typical connections on a job and are key to the economy of the fabrication and erection of that job. And so I tried to give some guidelines for designing safe and economical shear connections, regardless of whether the engineer of record or the fabricator designed the connections. There were certain information, certain basics that could be followed to come up with economical connections. This Higgins Award meant a lot to me. First of all, because so many of the previous award winners were people whose work I admired. In addition, I had the opportunity to work for AISC when Ted Higgins was leading AISC through all of the landmark changes in the specification in the 60s. It was an era of change that we'll never see again, at least that volume of change and something like that. After his retirement, I had the opportunity to share a cab ride with Ted one time in Chicago, and you had the sense that he was very precise in all of his comments and carefully thought out words and stuff like that. And that's what I remember from the sense of the Institute at the time. You didn't publish anything unless it was right. Being that the award was in his name, I felt especially honored.
I understand that you have a standing $5 bet with Jim Fisher on the Vikings-Packers games, and that you are very creative in how you pay up, if you have to pay up.
This is currently a very tender subject because the Vikings have been on a losing streak, you know. We've had a $5 bet for a number of years on each game. And I think the Vikings lost one of the first games, and Jim, of course, took special pleasure in continually asking for his $5. So finally what I did is I went out and got 5 $1 coins. And I went out in the shop and took a pair of clip angles and put the coins between the clip angles and then put 2 tension control bolts in and twisted them off. And sent the clip angles to Jim. And they're still on his shelf, by the way.
I was going to say, I bet that's still where they are, is between those angles.
Painted green and gold for the Packers. But his response was when the Packers lost the next game, shortly after I got in the mail a mortar cube with 5 $1 coins embedded in the mortar cube.
Do you still have that somewhere?
I still have that in my office also. We decided that was getting to be too much work, so now we're settled down to just exchanging money, but which reminds me, I have not paid this year's bet yet.
And, when he hears this.
he will definitely remind me again.
I bet you were really disappointed that they didn't get into the Super Bowl. The Packers didn't make it in the Super Bowl this year.
As with 2 minutes left to go, I placed a phone call that I never got a response to, something about turn out the lights, the party's over.
What would you say is your greatest professional achievement so far?
I get a great deal of satisfaction out of traveling the upper Midwest, and in particular the Minneapolis area, and seeing all the buildings that had a part in the fabrication and erection construction of. I mean, I'd like to think that I've made a contribution to my community in that, and I can go around and I like to be able to point them out to my children or whoever I'm traveling with, talking about, yeah, we worked on that one and we worked on that one, you know. I've also had the opportunity to work on projects with some of the top engineers and architects in the country, and I've enjoyed the knowledge that I've been able to be involved in their work. So I think that's it, the success of the projects that I've been involved in.
Well, that is a great achievement. You're very prolific in writing technical papers, and you do a lot of lecturing for AISC and other groups. What motivates you to write and lecture on technical topics?
As an undergraduate at Marquette, we were encouraged to, as a professional, to be involved, and including joining the ASCE student chapter, and things like that. Then when I went to work for AISC, Bob Desquay and Bob Lorenz encouraged us to join the organizations and write papers and things like that. My first published paper was as I was leaving AISC. I had been involved as an AISC regional engineer in the design and construction of the first staggered truss system in the United States. And so with the structural engineer of record, Harold Bakke, he and I did a paper for Civil Engineering Magazine, which was my first paper. Mm-hmm. I also mentioned that Dr. Fazler Khan was a hero of mine. I was privileged early in my career to serve on an AISC educators panel with Dr. Khan. Mm-hmm. And I was impressed with his openness and his willingness to share his experience. I can still remember his excitement talking about how he first presented his bundled tube system for the Sears Tower. It'll always be the Sears Tower for me, by the way, regardless of name change.
Mm-hmm. Yeah, understandable.
And I also knew that even with his busy schedule, that he found time to teach. And I was impressed. It really sort of inspired me to say, this is what a professional should do. Mm-hmm. People like that, and friends like Jim Fisher and that who are active in the profession, I think have sort of set an example for me that I've tried to follow.
What advice do you wish that you would have had when you were starting your career? Is there anything you wish you'd known?
I suppose you could say ask for the money before doing the work, but that's only partially kidding. I think some of the best advice I received was to do neat, complete calculations and sketches that would be easy to follow and check. My professor at Marquette was Ralph Beck. And Ralph had been chief engineer for Warden Allen, who had been a big steel fabrication company, and he was a structural engineering consultant on mining equipment and stuff like that. We always referred to him as Curly Beck, of course, because he was bald, But he told a story on how on his first job he would stay up all night working on the design problem using all of his reference books and that. The next day he would go into the office and spend his time neatly recopying all the calculations for presentation, stuff like that. Mm-hmm. But I think it helps your thought process also to be able to organize your work and be able to go back and review your own work and that,
And then a year or two down the road when they're actually building it, you can look at that and know what you were doing.
Yes.
And remember it if you have it all nicely organized.
Yeah. I don't know what happens now. I suppose you can page through pages, stacks of computer printouts and see what took place. I don't know.
Yeah. I didn't like doing that while I was designing, let alone a year or two later when you're like, what was I doing? I don't remember why I did this like this.
I work with Victor Schneer, of course, who's a very talented connection designer, and he was telling me today that he's got a project where they're insisting that he does his connection sketches on AutoCAD, and he says it takes at least 5 keystrokes to draw a line, whereas if I'm doing it by hand, he says I can draw that line and think about the sketch at the same time. Mm-hmm. Mm-hmm. So there's something about being able to think about something while you're drawing it and sketching it. Mm-hmm. That whereas if you're simply punching a keyboard, I'm not sure you're always thinking about what you're doing, and that hand-mind coordination isn't there.
Mm-hmm. I've also noticed that as detailing goes from hand detailing, the detailers that would do it by hand, as it moved more and more to computer output, that something seemed to get lost somewhere in the translation. I don't know if it's just because the guys that were doing it by hand had been doing it forever and they were just really good at it and had a lot of experience, but I noticed that I was always much more excited to get shop drawings that were drawn by hand than the ones that came as a stack of computer output.
Yeah, there's a lot of great advantages to the computer printouts and all that sort of stuff in computer detailing, but as you say, I can remember the old-time detailers we had, when they were drawn, they were thinking of how the building goes together. Mm-hmm. I mean, they were visualizing the project and how this piece would fit into the other piece that they had done. I don't know how we can get the advantages of the new technology, but some of the advantages of understanding the project better.
Yeah, that's the trick. You've been saying that you're going to retire for the last decade, but you seem to still be going strong and busy as ever. Do you have any real plans to retire anytime soon?
Every year I keep saying I'm going to take more time off and gradually get back from, move out of this. But then I get involved working with the young people at our company, which I enjoy so much. We're fortunate here at LeJeune to have, from our top management right down through the project managers and detailers and shop people, to have really good people who are fun to work with. And I really enjoy mentoring these people in that. And they also do a nice job of stroking me periodically, telling me how good it is to have me there. So it's nice to be appreciated. I guess I would say that.
And great that you're still wanting to pass your knowledge and experience on.
Of course, when I have to get up for a 5 a.m. flight to go to Chicago, I sometimes think I should retire.
What do you see as the next big innovation in structural steel or connection design?
Well, I mentioned BIM before, and I think BIM coupled with the analysis and design programs nowadays are the way everything's going, at least on all the major projects. And when we are able to fully integrate this BIM, the analysis and design programs, with connection design, and then the ability to download all of the CNC data to our new era of shop equipment, I think we're going to have some real advances in that. I think we can do the complex structures that architects seem to like to do these days, We're currently working on the fabrication of 4 long-span continuous trusses for retrofit of a Mississippi River bridge. And we've completed the fabrication of it. These bolted trusses were detailed using Tekla, and then all of the fabrication information was downloaded to a CNC Peddinghaus plate processor and a drilling line. We drilled all the holes full size. We shop assembled the trusses to confirm the fit, and we found the fit was so good that we had no rework required.
Wow.
And 3 of the trusses are already up in the field without any real problem. So we're using that same technology on another project, a major building project. We've started the assembly there, and the people that are doing outside the independent lab doing the testing is commenting on how well everything is fitting and that. So there's some real things that are taking place now in the improvement of shop equipment, plus being able to do all the downloads so you don't have any errors in transmission of data and stuff like that.
If you weren't an engineer, what other profession do you think you would have liked to try?
I don't know. Originally I wanted to be a physicist. But I was, when I got to college and I saw what type of math a theoretical physicist was required, I decided that wasn't going to be a lot of fun. As a young man and in the early college, I played football, and I would have enjoyed doing that. But probably the thing that would be best is one of my early high school aptitude tests said I had the aptitude to be an editor.
Oh.
And I think I would have enjoyed that. And I think committee work is to some extent being an editor. You take input and you try to organize it so everybody can clearly understand what the words say and that. To that extent, I think I am sort of being an editor as I work on all these code committees and stuff like that.
Well, Larry, thank you so much for taking the time to talk to me today. It's been a pleasure.
Margaret, it's been enjoyable. I've enjoyed doing seminars with you and look forward to maybe in the future doing some more and that. So
absolutely.
This has been a presentation by the American Institute of Steel Construction. For more information on AISC continuing education opportunities, please visit us on the web at aisc.org/seminars. And remember, there's always a solution in steel.